Hello, this is Algebra Honors, Unit 8 on Quadratics, Day 5. So we are going to warm up with some real-life applications, which that usually means we're going to do word problems. And we're using the quadratic formula. For this whole unit, we've been finding the values for x that make the whole function equal to 0. That is our whole point. And so we used factors to figure out what x values could give us 0. We took the square root of each side when we did not have any x term at all. And sometimes we used completing the square as a strategy. And today we're going to practice what we did in our last class, which is using the quadratic formula. All right, each time we're going to read through the problem and write some sort of an equation for the situation. Make sure we have it in standard form and set equal to 0. We're going to solve it. Then we want to think about our answers. Is there anything that's impossible? If so, we're going to get rid of it. So impossible answers are things like negative time. We're not going back in time, so we're just going to reject a negative time answer or negative distance or negative length or something like that. Okay, so once we've gotten rid of our impossible answers, we're going to answer the question that was being asked and move forward from there. In this case, we're going to round our answers to the nearest hundredth because that's what the instructions tell us, and so we're not going to leave anything in radical form. All right, so number one, I have a rectangular garden. Here's my garden. And I am told that the area, I'm told a rectangular garden needs to cover 513 square feet. So I know that's the area. Okay, the length of the garden is 8 more than the width. So if this is the width, then the length equals 8 more than the width. Okay, so I know the area is going to cover 513 square feet, but I also know area is length times width. That's our general formula. But I also know that my length is 8 plus w. So I'm going to write this as 8 plus w times w, right? Length is 8 plus w. I'm just substituting. So I see that I'm going to end up with a quadratic right here. So I know 8w plus w squared right here, I just distributed that, is my area, and I know area equals 513. Well, I'm nearly there. I've at least written an equation to talk about my situation, but I want it in standard form. So I'm going to write this as w squared plus 8w, and I'm going to subtract 513 from each side and set that whole thing equal to 0. This is what I'm going to work with, okay? And it is a quadratic that I have set equal to 0, which means I can find my variable if I solve this. So I'm going to solve using quadratic equations. So remember, we want a equals 1, b equals 8, and c equals negative 513. I'm going to use the quadratic formula which you have on this paper, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. That's my quadratic formula, so I'm going to use that with my a and my b and my c. So except for, I'm not looking for x, I'm looking for w, right? So I'm going to say w equals negative b, so negative 8, plus or minus the square root of b squared minus 4 times a times c, don't lose your negatives, that's negative 513, it needs to be there, all over 2a. All right, so I'm going to start simplifying. Okay, so I have negative 8 plus or minus the square root of 64 minus, it's going to be minus 205, sorry, it's going to be minus negative 2052. So minus a negative is plus 2052, and that is all over, whoops, 2a. I mean to say 2 times 1, because a is 1. So 2 times 1 is 2. Okay, I'm going to simplify over here so that I have more room. W equals negative 8 plus or minus, if I add these guys together, I'm going to get 2116. It's all over 2. And it turns out 2116 is a perfect square. So this is negative 8 plus or minus 46 is what it ends up being. Let's make sure. 2116 square root 46. Okay, this is all over 2. So this plus or minus here means that I'm going to do negative 8 plus 46 all over 2. And also I'm going to do negative 8 minus 46 over 2. Okay, these are going to be my two answers if they both make sense. And so I have 38 over 2, which is 19. And I also have negative 27, negative 54 over 2, which is negative 27. So those would be my two answers. But I'm thinking about width of a garden, and I know I'm not going to use a negative width because that doesn't make sense. So I solved for W, and I got W equals 19. W equals 19. Well, my picture here says that my width plus 8 is going to be my length. So this means my length must be 19 plus 8, which is 27. This should be my answer. And if I want to just double check, we know area is length times width, right? Area is length times width. So I'm going to check my work if I can. So length times width would be 27 times 19. And when I multiply those together, I get 513. So check, I believe my work is true. Right? We made an equation, we solved it, we checked our answers to make sure that they were logical, and we realized we don't do negative distance, and so we solved and used just one of those possible answers. We needed to solve for both dimensions, not just one, and so we plugged in and got our second dimension. All right. My next problem, Alex throws a ball straight in the air. He wants to know how long it's going to take for that ball to land on the ground. So he wants to know how long. I'm looking for time. Okay, if the ball leaves Alex's hand 4 feet above the ground and it is thrown at 25 feet per second upward, then this equation, h equals negative 16t squared plus 25t plus 4, models the path of that ball. Okay, he's going to throw it. Can't see that. He's going to throw it up in the air, it's going to go up, and then it's going to come down, right? That's a parabola, so that's what's happening. Now, some information we can get directly from our word problem. It's starting at 4 feet. It must say that right here. Starting at 4 feet, that's where we got this 4. And the velocity is 25 feet per second. That's where that 25 comes in. That negative 16 before the t squared came from smart physics people who helped figure out the acceleration and the gravitational pull and stuff like that. So we're going to trust that their equation is correct. How long will it take for the ball to hit the ground? The ground, what is our height when we are on the ground? Our height is 0. So when h equals 0, what is t? Well, that is just a quadratic equation. 0 equals negative 16t squared plus 25t plus 4. So I'm going to plug it all in. I know a equals negative 16, b equals 25, c equals 4. Negative 16, 25, 4. And I know x equals, except for in this case it's going to be t equals, right? T equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So I have a big old equation that I'm working with, and I'm going to use a calculator to help me. So I have time equals negative 25 plus or minus the square root of, well, 25 squared is 625 minus 4 times a times c. So 4 times negative 16 times c4 again. So that's minus negative 256. Minus a negative is really plus, right? So plus 256 all over 2a. 256. You could almost see my number. Okay, I'm still solving. I'm just simplifying. I'm still solving for t, so I have negative 25 plus or minus the square root of 881 all over negative 32. I'm checking it out. I don't think 881 is a perfect square, so I'm going to take the square root of 881. It's 29.68, so I'm going to use 29.68, okay? So this means that I'm going to say I have negative 25 plus 29.68 all over negative 32. That's one possibility, and the other possibility is negative 25 minus 29.68 all over negative 32. Okay, once I've established both of those, I'm going to see if I can figure that out. So this is going to be 29.68 minus 25 is going to be 4.68 over negative 32. So 4.68 divided by 32 negative, that equals negative 0.15 if I round to the nearest hundredth. My other option is I say negative 25 minus 29.68. So I get negative 54.68 over negative 32. And that gives me 1.709. So we are relying heavily on calculator for these. Okay, those are in 1.71 if I'm rounding to the nearest hundredth. So why don't I just round to the nearest hundredth here? Come on, special tape. Okay, we're going to say 1.71 because I'm rounding to the hundredth because I'm following instructions. Okay, the question was how long did it take for that ball to hit the ground? Well, it was either negative 0.15 seconds or it was 1.71 seconds. We're not going back in time. We're not going to use negative time. So we are going to say the time it took was 1.71 seconds. Okay, that is my answer. All right, moving on. We got 4 questions like this. Number 3. Manny launches a rocket from the ground at 55 feet per second. On the way up, it landed in a tree 40 feet high. The flight path of the rocket is modeled by the equation h equals negative 16t squared plus 55t. How long did it take to get there? So I want to know time when we are at 40 feet of height. Okay, so height equals 40. So let's plug that in, right? They've given us an equation. We're going to use it. And I know height is 40. So I'm going to write over here so I have more room. 40, that's my height, equals negative 16t squared plus 55t. I want to solve for t, so I'm going to set it equal to 0. 0 equals negative 16t squared plus 55t. I'm subtracting 40 from each side. That's how I got it equal to 0. I just subtracted 40 from each side. Okay, so this is the equation I'm working with. And I want to know what is t when h equals 0. Nope, when h equals 40, sorry. So h equaled 40, and I rearranged. Now I need to know what is t when the whole function equals 0, because that's how I solve for t. Okay, so let's go. I know t equals negative b, so I need to figure out my a and my b and my c. A is negative 16, b is 55, c is negative 40. Okay, a, b, c. So x equals, except for in this case it's t equals negative b plus or minus the square root of b squared minus 4ac 4ac all over 2a. Okay, just like before, we're just going to keep simplifying. And I'm coming over to the left of my page. T equals negative 55 plus or minus. Well, let's see what this doozy amount is. Okay, 55 squared, 3,025. So plus or minus the square root of 3,025 minus 4 times negative 16 times negative 40. So I'm going to say that is minus times minus is positive times minus again is negative. So minus 2560. And it's all over negative 32. I'm going to do that math again. Hold on, just I want to check my work. All right, so t equals negative 55. What did I just decide? Plus or minus the square root of 3025 minus 2560, 465, all over negative 32. And so now I'm going to actually do that as a decimal. So I have negative 55 plus the square root of 465. So negative 55 plus 21.56 all over negative 32. And my other option is negative 55 minus 21.56 all over negative 32. Okay, when I do that, I get 1.05 or 2.39. Whoops, 1.05 or 2.39. So here's the thing now. We are going to reject any answers that don't make sense. So we're going to think about this. Manny launched the rocket from the ground, and on the way up, it landed in a tree 40 feet high. How long did it take to get there? So you guys, here's our tree, right? There's our tree. Manny launches his rocket. Here's his rocket. And there's flames coming out of the bottom of the rocket. So he launches his rocket. It goes up in the air and boom, gets stuck in the tree. If it could continue going up and then coming back down again, you can see that it's going to hit this 40 feet high twice, right? It hits it on the way up and then on the way down, because that's what parabolas do, yeah? But we know it landed in the tree at 40 feet on the way up. So I'm going to think in terms of time, I want the first time it hit that 40 feet. So the first time it hit the 40 feet was when time equals 1.05 seconds. So I'm going to say only that first time made sense, 1.05 seconds. Okay, if it hadn't gotten stuck in the tree, if it had gotten to continue up and then come back down again, it also would have hit 40 feet at 2.39 seconds, but we only want the first one. Okay. Baseball player, this is number 4. A baseball player standing at 6 feet hits a ball with a velocity of 46 feet per second, and the path of the ball is modeled by this equation: h equals negative 16t squared plus 46t plus 6. How long will it take for that ball to hit the ground? Well, I need to realize when it hits the ground, that means h equals 0, right? So I'm going to say the whole height is 0. 0 equals negative 16t squared plus 46t plus 6. So I know A equals negative 16, B equals 46, C equals 6. I'm going to say x equals, except for it's t equals right now, t equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. And of course I'm just simplifying. Okay, so I know I have negative 46 plus or minus. I'm not squaring 46 in my head. 46 squared is 2116. So I want the square root of 2116. Negative 4 times negative 16 is going to be a positive number, so I know I'm going to be adding stuff. So I'm going to multiply 4 times 16 times 6. So I get 384 here. And it's all over negative 32. Okay, t equals negative 46 plus or minus the square root of, here comes my calculator, 2116 plus 384, 2500. Ooh, that's exciting. And it's all over negative 32. Square root of 2500, everybody? 50. Okay, so I know this means that I have negative 46 plus or minus 50, all over negative 32. Okay, negative 46 plus 50 is 4 over negative 32, which is negative 1/8. Which, if I want time, I'm probably going to say 1 divided by 8 is 0.125. But it's negative. So I'm being all careful in writing it all out, but I don't want negative time. That's probably not going to be my answer, right? My other option is negative 46 minus 50. So how about negative 96 over negative 32? So 96 divided by 32, it's going to be 3. Ooh, how exciting. 3. So 3 is my most logical answer. I'm going to say time equals 3 seconds. All right, so again, when we are using quadratic equations, we're going to make sure that we are set equal to 0 and we are in descending order, and then we're very carefully going to use our quadratic formula. Very carefully and methodically, because we don't want to lose any negatives. And we look at a word problem, try to come up with an equation that matches our word problem, and then we just solve. So thanks for watching. This is Unit 8, Day 5, and that was just our warm-up.